Greetings, mathematicians, and welcome to Semester 2 of Algebra 1. So the first unit that we will be talking about is System of Equations. So let's get going. All right, actually our winter hasn't been too bad. A couple cold days, but not bad at all. All right, let me get my screen going here. And you already have this made, and so you just need to take the notes on it. So what does system of equations mean? Well, it means we are trying to find the point of intersection of some data, okay? So there's three ways that we can do it, and one way is by graphing. And so we're just expanding on what we learned last semester. Really important that we know how to graph an equation that's in slope-intercept and to be able to solve for y. So you can see there's going to be three different types of solutions that we are going to have on the tabs. All right, so let's open up. So the first equation we have is 2x minus y equals 4. So we need to solve for y. So I'm going to allow myself a little extra room. So solving for y, we're going to get rid of 2x. Take that over to the other side. Make sure you bring down that negative with the y. Rearrange. We want this in point slope-intercept. So slope, and then the intercept would be positive 4 right now. But you can see we're going to have to solve for y. There's a negative on it. We're going to divide by -1. So let's see what that equation ends up equaling. Okay, so that gives us a positive y. 2 negatives equal a positive when we're dividing. 4 divided by -1 is -4. Okay, so I'm doing this in purple. A lot of kids like to use two different colors. So I'm going to plot -4, and I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1, okay? So now it's important that you end up using a straight edge. Draw a straight line as best as you can here. And I'm just telling you right now, all of our point of intersections should be integers. So we won't get a 0.5 or a 0.2. So it will cross on the graph at integers. Okay, now let's check out the second one. I'm going to use a different color here. Y equals 1/3 x plus 1. Okay, so it's already in slope-intercept. I'm going to plot at 1. I'm going to go up 1 over 3. Up 1 over 3. Okay, so we can see that we are crisscrossing where the point of intersection is. And that's actually called the break-even point, and economists use this all the time, or businesses, when they're trying to figure out, hey, what is it we have to do to start making a profit? You know, what's our expenses? What are we going to sell items for? And so this is practicing to be able to solve something like that. So our solution is where they crisscross. So start at 0, 0, 1, 2, 3, and up 2. Our point of intersection is 3, 2. And so you can see on the tab, we have one solution. Let's check out the next situation. Now it says no solution. So let's see what happens on a no solution. So again, I'll use two different colors. Purple, this is already in slope-intercept, which is kind of nice. I'm going to plot at +1. This time I'm going to go down 2 and over 3. It's a negative slope. Down 2 over 3. Down 2 over 3. Okay, and again, just try to draw, use some type of straight edge. Draw a straight line there. All right, the second one, we notice it's in standard form. We have to solve for y. So I have enough room here, I'll go ahead and use it. I'm going to subtract 2x from both sides. I get 3y, rearrange, those aren't like terms. Put my x term first and then my constant. And now I need to still solve for y, so I'll divide everything by 3. And I get a solution of negative 2/3 x. 9 divided by 3 is 3. Okay, so one thing I'm noticing right away is, oh, the slopes. Okay, check out that slope. Check out this slope. So what we learned in our last unit, first semester, is when we have two lines that have the same slope, they should be parallel. All right, so let's check it out. So we're at positive 3. We're going to go down 2 over 3. Down 2 over 3. Okay, and then when I draw that, let's see if I might have been off just by 1 there. Okay, down 2 over 3. Let's make sure I get it graphed right. And this is a little bit tougher. We don't have the greatest grid marks, I'm going to admit that. So here we have two parallel lines, and we have a no solution. And that's actually what we say. We just put no solution. In a two-dimensional world, parallel lines will never crisscross each other, and so we have no solution. All right, last situation. All right, the first one is in slope-intercept. It's ready to graph. So I'm going to plot the 3, that's your y-intercept. I'm going to go down 2 over 1. Okay, and plot a few, you know, I like doing a few extra points. I think that helps. And again, your graphs will have definitely better grid marks. Okay, these aren't the greatest. It just didn't print off that great. Okay, next one. This is in standard form. We need to solve for y. Okay, take your x term over to the other side, do the inverse operation. It's a positive, so we subtract 4x. Rearrange. It's almost in slope-intercept. We just need to divide by 2. Y equals negative 2x. Simplify there. And 6 divided by 2 is 3. All right, now I am noticing it is the same graph. It's the same exact equation, so it's going to be the same exact graph. Now, do I need to plot it? No, but it would just end up, it's kind of a weird situation, it's the same exact line, okay? Same exact line, and we know that. They're both in slope-intercept. We can see it's the same identical equation. So that answer is all solutions. And I guess it says on the tab, many solutions. But of course, I like to make that infinity symbol. It just means that it doesn't matter what we substitute in, it's going to be on that line no matter what. All right, so those are the 3 different situations we can have. I would say 90% of the time, we're going to have one solution. And maybe 5% no solution, 5% of the time. So expect to have a one solution, but be observant. If you notice that the slopes are the same, you automatically know those should be parallel lines. If you see that the equations are identical, recognize that it's going to be the same line and it's going to be all solutions.